My name is Samuel. You know my name already. Okay? In this video session, we shall multiply matrices. This is the third part of the video playlist on matrices. Here we shall do multiplication of matrices. Multiplication of matrices. We have two types of multiplication of matrices. When we talk about multiplying matrices, we have two types. It could be the scalar multiplication or it could be matrix multiplication. Now, when we talk of scalar multiplication, we are talking of a scalar quantity, like a number, multiplying a matrix. Okay? When we talk of scalar multiplication, we are talking of multiplication of a matrix by a number or by a scalar quantity. Now, when we talk of matrix multiplication, we are talking of two matrices multiplying themselves. Two matrices being multiplied together. A matrix being multiplied by another matrix. That is what we call matrix multiplication. Now, scalar multiplication is straightforward. We shall go ahead and start solving questions right away. With scalar multiplication, we multiply all the elements of the matrix with the scalar. When we do scalar multiplication, we multiply all the elements of the matrix by the scalar. For instance, if we have with scalar multiplication, we multiply all the elements of the matrix by the scalar quantity. Okay, of course, you know what a scalar quantity is. A quantity that has magnitude but no direction. We did that in physics. For instance, assuming I have maybe, assuming that if matrix A is A11, A12, A21, A22, A31, A32. Okay, find negative 5A. Find negative 5A. So the scalar here is negative 5. So what we have to do is we multiply every element of the matrix A by negative 5. That is what we'll do. So we have that negative 5A means negative 5 times A11, A12, I'm doing it by row, A21, A22, A31, A32. So this will be negative 5A11, negative 5A12, negative 5A21, negative 5A22, negative 5A31, negative 5A32. The scalar, with scalar multiplication, the product has the same size as the matrix. The product has the same size as the matrix. The product has the same size or dimension as you might call it, has the same size as the matrix. Now let's do some examples on scalar multiplication before we now talk of matrix multiplication. So let's go ahead and solve some examples. Number one, 1, 2n, m, negative 3, minus 4 times 2, negative 2, 0, 3, equal to 3p, 4, 10, negative q. Now, this is a situation of both scalar multiplication and equality of matrices and subtraction of matrices. We have three things that we do here. We have to multiply, and then we subtract, and then we now equate it. So, scalar multiplication, subtraction of matrices, and then equality of matrices. Now, as you do PEMDAS, right? You do PEMDAS. So we can go ahead and multiply this. It does not matter. This is minus. This will be what? 4 times 2, 4 times negative 2, 4 times 0, 4 times 3. And then you can write this 1, 2n, m, negative 3, equal to 3p, 4, 10, negative q. So this becomes what? 1, 2n by column, m, negative 3, minus, this becomes 8, 0, negative 8, 12, equal to 3p, 4, 10, negative q. We now subtract, this becomes 1 minus 8, m minus minus 8, 2n minus 0, minus 3 minus 12, equal to 3p, 4 by column, 10 minus q. This becomes negative 7, m plus 8, 2n, negative 15, equal to 3p, 4 by column, 10, negative q. We can now do equality of matrices. When we do that, what do we have when we do that? We have that negative 7 is equal to 3p. So this tells you that 3p is negative 7, and p will be negative 7 over 3. We got our p. Then we have that m plus 8 is equal to 10. M will be 10 minus 8, and m will be 2. We got our n. 2n is equal to 4, so n will be equal to 4 over 2. N will be equal to 2. We got our n. And then negative 15 is equal to negative q. Negative q is equal to negative 15. We divide both sides by negative 1. So q will be equal to 15. We got our q. And that becomes your answer. Question 2, we have that 2 times negative 4 by column, 0, 4, negative k, negative 1, 4, equal to negative 3 by column, p minus 1, 1, 4, 2, 2, 2q plus 1, plus by column 1, 3, t, 2, 4, negative 1. So you have this. This we have a scalar multiplication by negative 3. Negative 3 is the scalar. Then we have a addition of matrices. Then we have a equality of matrices. We have another scalar here. Scalar multiplication here by 2. Scalar multiplication here by -3. Addition of matrices here, and then equality of matrices. So this becomes what? 2 times -4, 2 times -k, 2 times 0, 2 times -1, 2 times 4, 2 times 4, equal to -3. Now, when you're doing this now, be careful. This is a -3 times p minus 1. P minus 1. You have to put this parenthesis. Some students will go and put -3p minus 1. You know, they come here, p minus 1, they come and put -3p minus 1. This is wrong. It's wrong. You don't do this. When you have an entity, when you have this as an entity, you have to multiply everything by -3 and apply the distributive property. So take note of that. Then this is -3 times 2, -3 times 1, -3 times 2, -3 times 4. Then the same thing here is an entity. Treat it as an entity. -3 times 2q plus 1. Then plus 1, 2, 3, 4, t, -1. I did this by row. All right. So this will be -8, -2k, 0, -2, 8, 8, equal to, now go ahead and, you can go ahead and expand this. This is -3p plus 3, -6, -3, -6, -12, -6q minus 3. Yeah, please do it gradually, you know. And I would like you to kind of try it. You pause the video as usual. Do it on your own before you continue. Then to check your answer whether we got the same thing. Plus 1, 2, 3, 4, t, -1. Now, something we probably didn't check here, although is correct, is to make sure that they are the same size. Remember, in the previous video we talked about it. Before they can do addition, before you can do the addition or subtraction or equality of matrices, they must be the same size. Okay? Now this will now be what now? Let's go ahead and finish this up. -8, 0, 8, -2k, -2, 8 is equal to -3p plus 3 plus 1, -6 plus 2, -3 plus 3, -6 plus 4, -12 plus t, -6q minus 3 minus 1. Be careful on this, please. Be careful about it. And then you can now do equality of matrices. Yeah. This would be -6q minus 3 plus minus 1. Plus minus 1 means, you know, plus minus 1 means is plus minus is minus. Just take note of that. Here should have been plus minus 1. Plus minus 1. And that will still give you minus. Okay. We now have that negative 8, 0, 8, negative 2k, negative 2, 8 will give us, let's get this done, okay? Negative 3p plus 4, 0, negative 12 plus t, then this is negative 4, negative 2, negative 6q, minus 3 plus minus 1 is minus 3 minus 1, which is minus 4. Now you can now do the equality of matrices. We have that negative 8 is equal to negative 3p plus 4. Let's rearrange that. Negative 3p plus 4 is negative 8. Negative 3p is negative 8 minus 4. Negative 3p is negative 12. P will be negative 12 over negative 3. P will be equal to 4. You have your P. Then you have that here, negative 2k is equal to negative 4. K will now be equal to negative 4 over negative 2. And K will now be equal to 2. You have your K. 0 is equal to 0. That's good. Negative 2 is equal to negative 2. That's good. 8 is equal to negative 12 plus t. You rearrange that. Negative 12 plus t is equal to 8. T will be equal to 8 plus 12. T will be equal to 20. Then 8 is equal to negative 6q minus 4. Negative 6q minus 4 is equal to 8. Negative 6q is equal to 8 plus 4. Negative 6q is equal to 12. Q will be 12 over negative 6. Q will be negative 2. That's it. And if you want to check this, you can check it. I probably would like you to check it. It's good because it's equality. You know, anytime you have equation, Mr. CEO always wants you to do what? Check your work. You can check it. And this is a quick way to check it. You can even check it mentally, but I would like you to check it, you know, by solving it. This is 4. 4 minus 1 is 3. 3 times negative 3 is negative 9. Negative 9 plus 1 is negative 8. And that 2 times negative 4 is negative 8. Yeah, you can check it that way. But because of time for video, you know, I don't want to check it. But ordinarily, I would check it. I encourage you to check it, to check your work. Number 3, we are doing what you like next, which is the fractions. I know you like fractions next. So we are going to solve this fraction, and it is 3 of them. It involves both the scalar multiplication and then addition of also, and then subtraction. So you remember your PEMDAS, right? You remember PEMDAS at least. We are going to use this here. We shall first of all do the scalar multiplication, and then after that we do addition from left to right. Addition from left to right. So I would want us to kind of do the scalar, do 2 at a time first. Let's do 2 at a time first. Let's do these 2 first. Okay, let's do these 2 guys first. And then whatever we get, we can now do this, we can now handle this guy. Okay? So let's do the scalar multiplication first. This will be 1/2 times 1, 1/2 times 1, then 1/2 times 0, 1/2 times 0, 1/2 times negative 4, be close, then 1/2 times 3, 1/2 times 0, 1/2 times negative 1, 1/2 times 6, 1/2 times -2, 1/2 times 1, 1/2 times -4, 1/2 times 2. So if we do this, what is it going to give us now? This will be 1/2 times 1 is 1/2, 1/2 times 0 is 0, 1/2 times 0 is 0, 1/2 times -4, 2 divided 2 is 1, 2 divided 4 is 2, so this is -2. We close this. One-half times 3 is 3/2. 1/2 times 0 is 0. 1/2 times -1 is -1/2. 1/2 times 6 is 3. 1/2 times -2 is 2 divided 2 is -1. Of course, here is that 2 divided 6 is 3. Okay, that's why we got 3. You do this, patiently. You kind of want to, you don't want to make mistakes in this. 1/2 times 1 is 1/2. 1/2 times -4, 2 divided 1, 2 is 1, 2 divided 4 is 2, so this is -2. 1/2 times 2 will give you 1. Okay? Now you know that this is a what? This is a 3x4 matrix. We didn't write it, we have to write it. So this is 3x4 matrix. This one is also 3x4, and this is 3x4. So we can do the operations of addition and subtraction. Okay, so we got this now. We got this settled. Let's face this guy with scalar multiplication. This will be 4/3 times 3, 4/3 times 0, 4/3 times -1, 4/3 times 4, you close. Then 4/3 times -2, 4/3 times 1, 4/3 times -6, 4/3 times 2, 4/3 times 8, 4/3 times 2, 4/3 times 0, 4/3 times -2. So this will be, okay, plus, we bring down the plus. Let's see this. 4/3 times 3, this gives us 4. 4/3 times 0 is 0. 4/3 times -1 will give us -4/3. 4/3 times 4 will be 16/3. 4/3 times -2 is -8/3. 4/3 times 1 is 4/3. 4/3 times -6. 3 divided 3 is 1. 3 divided 6 is 2. This will give us -8. 4/3 times 2 is 8/3. 4/3 times 8 is 32/3. 4/3 times 2 is 8/3. 4/3 times 0 is 0. 4/3 times -2 is -8/3. Okay, let's go ahead. Now let me draw a line here. Let's go ahead and add this up. Add it up. Let's add these folks up and see what we get. So this is 1/2 plus 4. 0 plus 0. 0 plus -4/3. -2 plus 16/3. 3/2 minus 8/3. 0 plus, well, this is plus minus, okay? You can put plus minus 8/3. It's not, we'll still fix it to be one sign. 0 plus 4/3. negative 1 over 2 plus negative 8, 3 plus 8 over 3, negative 1 plus 32 over 3, 1 over 2 plus 8 over 3, negative 2 plus 0, and then 1 plus negative 8 over 3. So what would this give us now? This will be equal to 1 over 2 plus 4 is 4.5. We can just write 1 over 2 plus 8 over 2 so that we can put it in the same denominator. Let's leave our answer as improper fraction. It does not matter. Okay, 0 plus 0 is 0. 0 plus minus 4 over 3. Okay, plus minus is minus, so this is minus 4 over 3. And then minus 2 plus 16 over 3, this is minus 6 over 3 plus 16 over 3. Then 3 over 2 plus minus is minus, right? So let's write our minus. Now 3 over 2 minus 8 over 3, how do we have to put it to be in the same denominator. This will be 3 times 3 is 9 over 6, right? And 2 times 8 is 16 over 6. Okay? Okay, so then this is 4 over 3. Then this is 1 over 2 plus minus is minus. So this is minus 1 over 2 minus 1 over 2 minus 16 over 2. Right? Then this is 9 over 3 plus 8 over 3. Right? Let's do it and check it again to make sure that we are correct, you know. Do it and check it again to make sure that we are correct. Okay, the next one is minus 3 over 3, minus 3 over 3 plus 32 over 3. 1 over 2, this is 3 times 1 is 3, 3 times 2 is 6, plus 2 times 8 is 16, 2 times 3 is 6. Expressing the equivalent fraction. Then minus 2 plus 0 is minus 2. And then this will be 3, plus minus is minus. And this will be 3 over 3 minus 8 over 3. Okay, we check it again, you know. We kind of look at it again to make sure that we are correct, that we are not making mistakes. Because you don't want to make mistakes in this. You can still check this with Excel. After adding and subtracting, we will use Excel to check it. So watch out for my videos on technology, on matrices. Technology for matrices. Watch out for that video. All right. So let's finish this. This is our first part anyway. This gives us 9 over 2. This is 0. This is negative 4 over 3. And this is 10 over 3. This is a 9 minus 16. Is a minus 7 over 6. Minus 7 over 6. And then 4 over 3. Then negative 17 over 2, then 17 over 3, 32 minus 3 is 29, 29 over 3, this is 19 over 6, this is negative 2, and this is negative 5 over 3. So what we are going to do now is we have done this, so we have to use this to, minus this. So why don't we just do it here? let's erase this. So we can have some space to do this. So this is what we got here. We have 9 over 2, negative 7 over 6, 29 over 3, 0. I'm calling it by column. 4 over 3, 19 over 6, negative 4 over 3, negative 17 over 2, negative 2, 10 over 3, 17 over 3, negative 5 over 3. Okay, this is minus. Now, let's get this guy. Okay, now this will be what now? This is 1 over 3 times 3, 1 over 3 times negative 9, 1 over 3 times negative 1, 1 over 3 times 0, close. Then 1 over 3 times 6, 1 over 3 times 2, 1 over 3 times 0, 1 over 3 times negative 6, 1 over 3 times 0, 1 over 3 times 1, 1 over 3 times negative 3, 1 over 3 times 1. Okay, so this what will this give us? Let's write. This will give us. Let's write this down again. It does not matter. 9 over 2, negative 7 over 6, 29 over 3. Then this is 0, 4 over 3, 19 over 6, negative 4 over 3, negative 17 over 2, negative 2, 10 over 3, 17 over 3, negative 5 over 3, minus 1 over 3 times 3, this is 1, this is negative 3, this is negative 1 over 3, this is 0. Okay, I've done the multiplication, just multiplying fractions. You can watch my video on that, multiplying fractions. Then this will be 2. 1 over 3 times 6 is 2. 1 over 3 times 2 is 2/3. 1 over 3 times 0 is 0. 1 over 3 times negative 6 is negative 2. 1 over 3 times 0 is 0. 1 over 3 times 1 is 1 over 3. 1 over 3 times negative 3 is negative 1. And 1 over 3 times 1 is 1 over 3. So let's finish this stuff. Let us finish this. Let us finish this work, okay? So this is going to be what now? From here, this will be 9 over 2 minus 1, 0 minus minus 3, minus 4 over 3, minus minus 1 over 3, 10 over 3, minus 0, negative 7 over 6, minus 2, 4 over 3, minus 2 over 3, minus 17 over 2, minus 0, 17 over 3 minus minus 2. 29 over 3 minus 0. 19 over 6 minus 1 over 3 minus 2 minus minus 1 minus 5 over 3 minus 1 over 3. So this will be 9 over 2 minus 2 over 2. Let's put it in the same denominator. 0 plus 3. This is a negative 4 over 3 plus 1 over 3. This is 10 over 3 minus 0 is 10 over 3. This is negative 7 over 6 minus 12 over 6. This is 4 over 3 minus 2 over 3 is what? 2 over 3. Right? 2 over 3. Negative 17 over 2 minus 0 is negative 17 over 2. Then this is 17 over 3 plus 6 over 3. Okay? Because minus minus is plus. Then this is 29 over 3. Then this is 19 over 6 minus, this is times 2 times 2, 2 over 6. Okay? And this is minus 2 plus 1. And this is minus 6 over 3. Minus 6 over 3. So this is going to be what now? What are we going to get as our answer for this? This will be 9 minus 2 is 7 over 2. 0 plus 3 is 3. 1 minus 4 is minus 3 divided by 3. Okay. Negative 4 plus 1 is negative 3. Divided by 3 is negative 1. Then this is 10 over 3. Okay. Then minus 7 minus 12 is minus 19 over 6. Then this is 2 over 3. This is minus 17 over 2. This is 23 over 3. This is 29 over 3. This is 17 over 6. This is minus 1, and this is minus 2. And this becomes your answer. This becomes your answer. You can, like I said earlier, you can check this.